Good morning, dear students. Last session we have had a recap of Unit 1, and this session we'll start with Unit 2 of our syllabus. Okay, so Unit 2 majorly to talk about two things. One is pre-stressing systems. Another one is estimation of pre-stress. Okay, or you can say simply analysis of pre-stress. So pre-stressing systems, we'll talk about the following subtopics. So we'll talk about tensioning devices, and we'll talk about what are all pre-tensioning systems available and post-tensioning systems available. Okay, and this is the content in pre-stressing systems we'll talk about. So to induce pre-stress, what are all the systems that are available uh, maybe right now or from the age old days, right? So this is what we talk about. So we'll talk about what are all tensioning devices available, what types of tensioning devices available, and also there are two types of pre-stressing. One is pre-tensioning, another one is post-tensioning. So we'll talk about what systems we take for pre-tensioning and what systems are available for post-tensioning. Okay, so pre-stress is induced by two ways. One is pre-tensioning, another one is post-tensioning, right? When it comes to the other half of the Unit 2, we have analysis of pre-stress. So we'll have some basic assumptions and all, and we'll talk about analysis of pre-stress and how to calculate resultant stress at a section, and what is a pressure line, and what is concept for load balancing, and to get stresses in tendons, how you get stresses in tendons, and finally how you get the cracking moment value, right? So this is about the second half of the unit. Okay, it is purely analysis of pre-stress, means how much pre-stress you are inducing to the concrete through the tendons. Okay, so this is about Unit 2 to talk about. So let's start with the methods by which we will induce pre-compression. What are all various variety of methods by which we induce pre-compression in concrete? Okay, so one such technique is flat jacks we use, and the use of these flat jacks are particularly to arches and pavements. Okay, these jacks may be of mechanical or may be of hydraulic. Okay, so the principle upon which they rely on may vary. Maybe mechanical jacks or can be hydraulic jacks, right? And the other technique is circumferential wire winding. So this is another technique that we use uh, pre-compression in concrete. So tanks, pipes. Okay, so these things we will use circumferential wire winding uh, to induce pre-compression in this nothing but hook compression, because when you take a pipe or a tank, so when fluid is inside, it is going to exert the pressure onto the walls of the pipe or the tank, so which will try to induce hoop tension. This is hoop tension that it will induce. So before the hoop tension comes, you know, somehow if you can induce a hoop compression into the pipe material, so this is something like the wire winding. If it is if you wind the wire around the pipe, so that will try to compress the pipe material. Okay, so that will induce compression, prior compression. So there will be compression already in the concrete, and when you allow the service of that particular member, maybe pipe or tank, if it is in service, means fluid enters, then tension starts appearing. So that will be counteracted by the compression which is already there. So final stress may be remaining value, some value of compression, or can be zero to the maximum zero. The tension will not be allowed into such tanks to remain. So if the tensile stress is, for example, 100 megapascal is expected, so you shall actually prior to this 100 to come to the material, you shall induce a compressive stress of 100 or more than 100. Okay, to not to have any tensile stress into that material. So final tensile stress shall be zero. Okay, right. So this is about the circumferential wire winding. And spun pipes are very popular. If you can go to the manufacturing site, you can see that. And the third technique to induce compression in concrete is like flat jacks. First technique is for applicable for arches and pavements. Okay, the flat jack is just nothing but a is nothing but a plate which is to be uh, kept, a flat plate which is to be kept and shall be pushed accordingly to induce compression into the member that is available just adjacent to that. So this is like we press the against the member, we press the edge of the member against that member, so that it is going to induce compression. Okay, and the third technique is to be used is tension steel in concrete or housed in a duct. It is nothing but pre-tensioning and post-tensioning technique. This is the widely used technique. So either prior to casting concrete, you can just pull the tendon and pour the concrete, let it to get hard, or first prepare the concrete member with a duct left for inducing the steel to induce the steel member for tensioning. So this is the way tension steel is used to induce pre-compression in the concrete. Okay, use of principle of distortion in indeterminate structures. Okay, if you have an indeterminate structure, so distortion can be used to induce pre-compression to the concrete. One part of the structure will be distorted to induce the stresses in the other part of the structure. That way you can plan. And the other technique which is possible is use of deflected structural members in concrete. So for example, if you have a beam to maybe simply supported beam, for example. You have a simply supported beam that is expected to bend down when the loads come. So what you need is, say, if you already have a steel member which is of hogging in nature, if you induce that deflected member, a steel member, into the concrete, and that will take care of this bending to counteract that bending. That is what is the purpose of this deflected structural steel members in concrete. Okay, so already a deflected structural member, you just keep it inside the concrete, so the load that is applied onto the concrete is also applied onto the steel member, and that will resist to bend down because of the bonding property between concrete and steel, and that is going to counteract the bending nature of the concrete also. Okay, and the final technique is expanding cements. So you use the expanding cement. For example, this is the concrete mold that is being kept. Okay, the mold for pouring the concrete. So into this mold, you just pour the concrete, which is prepared with the expanding cement. Okay, this is a concrete member, for example, which is prepared with the expanding cement. So what it will do upon setting, it will try to expand the length of the member will try to expand, so that will try to push the mold outward, so that mold will try to oppose that action, that will try to induce compressive force from the mold onto the concrete. So that is what is the technique which is to be used in terms of expanding cements. So expanding cement is the one such technique, but it is mostly used to to block the cracks and all. So mostly repair works will be done using this expanding cements, right? So out of all these techniques, most widely used method is the longitudinal tensioning of steel by different tensioning devices, like as I said, pre-tensioning or post-tensioning. Okay, so this is about various techniques that we have for pre-stress, not just the pulling the tendon and pouring the concrete. There are very variety of techniques to impart pre-stress in concrete. Okay, these are all the different techniques, out of which the one which is famous and which has got propagated much is like tension steel in concrete. Okay, maybe pre-tension or post-tensioning technique. Okay, either pre-tensioning or post-tensioning technique can be widely used. Right, let us talk about tensioning devices. What are all types of different tensioning devices? Because we are talking about tensioning in the sense pulling the tendon, okay, pulling the wire. So what variety of devices you have to uh, pull the tendon? Okay, so main purpose is to pull the tendon. So it can be mechanical, or it can be hydraulic, or it can be electrical, or it can be chemical. So these are the devices which will be used for tensioning. So what are all mechanical devices available? Let us see. For tensioning the steel. Okay, weights with or without lever transmission, geared transmission with pulley blocks, screw jocks, with or without gear drives, and wire winding machines. So these are the different varieties of mechanical devices that we have to pull the tendon. Okay, so either you can use the weights, okay, with or without lever transmissions, and the geared transmissions with pulley blocks, screw jocks, okay, screwing the tendon will also will try to induce tension. Or pulley blocks can also be used for tensioning. Okay, just imagine that you have a mold where steel rod is inserted. So have a pulley here, okay, and add some weight here. Okay, so this is like one end tied to the edge of the mold, and go on put the weights upon which you the calculated force that you want to induce into this steel tendon. So that will try to pull this tendon. This is one such technique. Okay, so either pulley blocks or can be weights with or without lever transmissions, or screw jocks. Straight away just screwing this tendon at one end, okay, by just bolting at the other end, we'll try to pull the tendon. So all these techniques are to just to tension the tendon, to induce tensile stress in the tendon, that will in turn transfer to the concrete as a compressive stress. Okay, the tension that is induced into the steel is transferred to the concrete as compression. Okay, right. Let us see hydraulic tensioning devices. Those are mechanical tensioning devices. Even you can attach a wire winding machine. So it will try to wind the wire, means it will try to pull the tendon. Okay, so such is the technique. And hydraulic jocks are very famous by different scientists like Fressinet, Magnell, Gifford, Woodall, and Bohr and Leonhardt. All these scientists have developed the hydraulic jocks for the purpose of tensioning the tendons to the scale of to induce the stress to the scale of 2000 megapascal, something like that. Okay, so this is how the hydraulic jocks will try to it's very famous and present all the industry of pre-stressing industry is using. A lot of devices have come around 65 around 60 plus, you can say 60 plus tensioning devices, patented tensioning devices are available right now. Okay, so among them whichever is to be used according to your convenience and availability in the market, you can use them. Right, how electrical tensioning devices will work. Okay, steel wires are electrically heated. That's called thermoelectric pre-stressing. Okay, just passing the current, passing the electricity through the steel wires will try to heat up the steel wire. Heating will try to expand the steel wire. That's how we can increase the strain in the steel. So this is another technique which is not widely used anyhow. It's very rare. Maybe just to study one of the types. Like, okay, so another technique is expanding cements, that chemical way of tensioning devices. is already discussed in the earlier slide, right? So mechanical devices and hydraulic tensioning devices, electrical, chemical. Among them, hydraulic devices are no, very widely used nowadays, right? And that too, these are the scientists which they have developed, Freyssinet, Magnell, Gifford, Udall, and Bar Leonhardt. Okay, right. So that's about the tensioning devices, what we talked about, and then the various methods. Not only just tensioning the uh, steel, the other techniques. What are all other techniques that we have for uh, compression to impart, right? And to start with the unit 2, pre-stressing systems, and the next session we'll talk about pre-tensioning systems available. Okay, right? So today's session we will ending up with this. So what are all we talked about? Let us see. So various methods by which pre-compression can be imparted to concrete. These are all various methods, out of which the very widely used and famously known as pre-tensioning and post-tensioning techniques, that is tensioning the steel. Okay, and then the devices, among the devices, mechanical, hydraulic, electrical, chemical. Hydraulic jocks are very widely used for tensioning operation, right? So from next session onwards, we'll talk about this pre-tensioning systems.